Right, we're carrying on with section 3, or arrays. So we'll cover 3 sections, which is the basic concepts of arrays, typical array processing code, and 2-dimensional arrays. So just note that Python itself doesn't have the formal definition of arrays in the programming language. We will be using lists and modifying lists to give the same expectation that you get in other programming languages. So when you speak about arrays, in essence, we're actually using Python's built-in lists data type. We're now about to try to explain this further on. All right, foundation for programming. We've covered quite a bit so far. We have covered primitive data types, assignment and statements, math, text IO, conditionals and loops, and now we focus on arrays. And this allows us the ability to store and process huge amounts of data. So arrays, it is a data structure. It is an array. A data structure is an arrangement of data that enables efficient processing by a program. An array is an indexed sequence of values, typically of the same type. So example, you have a deck of cards, you have 52 playing cards, you have 100,000 students in an online class, 1 billion pixels in a digital image, 4 billion nucleotides in a DNA strand, and this goes on to various examples of storing lots of data. So here's an example of how you have an index or position of where your value is stored. And the value itself, 2 of hearts, 6 of clubs, and so on for a deck of cards. So the main purpose is to facilitate storage and manipulation of data. So previously we've stored single value in a variable. Now we will be storing multiple values, a large amount of data, into a list or an array. So processing many values of the same type. So lists, just as a side note, allow you to store different types of data, ints, floats, and strings all at once. However, the more formal explanation of a array is it should be of the same type. So for example, the benefit of having arrays is, imagine you have 2 initialized variables from A to 8, for example, or further, and you want all initialize it to 0. You have to copy and paste it many times to type it out, which is very, very tedious. You can easily do this by just using a standard array library comes with Princeton to create a 1D array, which is a list of or one-dimensional list of values. And you can change them quite easily if you want to and add them. We'll get to actual practical examples of this. And you can also even create 1 million values with an array. So imagine you have to change these values as they go along. You can scale to huge amounts of data. So first, let's see how do we actually create this 1D array with this library from Princeton Python course. So if we go to Python and we import stdio and import the other std array, we can easily write this out. At the bottom in my terminal, I can say a equals standard array dot create 1D 10. And what this does is initialize 10 elements with this value of with the value of 0. There's a typo there, so it's actually supposed to be a 1D. The bottom capital B should work. So yeah, so there's the bottom over here. So then if we type A, we should get a list of 10 values or 10 items that initialize with the value of 0. You can change this as well. For example, if you want to access any values, I start with A0 is in programming, Python, and other programming languages, the first element is actually the 0th element. This goes into a bit more detail in the Princeton course itself, which I've done. So you can have a look about how to call and access elements. So you can also have a look here, but for the first element will be A0, then the second one, and the third one, and so on. I can also assign different values. I can say if technically the fifth element, I make it 3.0, and the eighth or the ninth one is 8.0. Let's say A again. You see that these values have now changed. And here's an example of the changing very big ones, but we won't cover that much more. So this is how you firstly create an array, like we've done. This is how you access it to actually visualize the value in it. And this is how you can change individual values in it. So this means list or arrays are mutable, they are changeable, and they can mutate. So Python lists versus arrays. And the standard array module, the one we're using, we just imported over here. So arrays are fixed length data structures. Python lists does not have an array data structure. That's why we're using standard array module from Princeton. A Python list is similar. Iteration, index access, index assignment iteration, so on. And to iterate to an array, but variable length. So that's the main difference is a list has a variable length, as arrays are supposed to be fixed. Here's an example of a Python list. If you want to create a Python list, if you want to create a Python list, let me just clear this. You can see doesn't work there. Interesting. Okay. So if you want to know how to clear a terminal, if other normal commands aren't working, you can say import OS or start system and it clears a terminal. So we're starting from the top. So as I mentioned, if you want to create a list in Python, we specified with empty square brackets. This is a unique feature of a list. It is square brackets. And I created an empty one, I can type X and I get like X, for example. I can say X is 1, 2, 3. Type X, I get 1, 2, 3. This is how you normally create a Python list. In this case, we specifying arrays, but this is how a list works. So here's an example of lists and how do you add to a list? Well, you can just say X is X plus like 0.1, for example, and then it would be you can add a value like that over there. So this is how you add values. They're using shorthand with this plus equals symbol. So it's the same, so saying plus equals, for example, 3.6. I would add 3.6 over there. That's how I'll just add a 3.6. There's another way of actually doing it. Again, they are trying not to use the Python way. They're trying to use more formal array structures, but you can also just say x dot append or a dot append, well, the arrays x dot append. Built-in function, that's just like 50 something like that. It's another way of adding numbers. Just want to check if you can say x equals x plus 10. Yeah, no, you have to, if you want to add values this way, you have to put it in a square bracket so it knows you're adding the correct data type. So it's complaining that, well, I'm trying to add a list to a integer, which is not correct. So in this case, you have to put the square brackets. This is an example of how this is done in Java, Java programming language, which is a very similar structure. Standard array module provides utility methods to create an array of n elements and initialize the given value. And there's documentation of that. So this again is how it's another example how to create this. So let's say, what is that? So clear the screen. There we go. Say X is standard stdarray, create 1D array, 3 elements, they must be initialized to 0.0, and that's how to do that. Let's find the length of X. It is 3. And here they are trying to assign values as well. So I want to say X, the first value is 0.3. Then next one is 0.6. And then it is 0.1. Let's see what I have, which is fine. Now they try to show an example here where I say, well, let's say X, the third index number 3, which is technically the 4th element. However, there are only 3 assigned values. So this actually won't work. If I say like 0.99, I get this assignment index out of range because I'm trying to access the 4th element, but it does not exist. So just keep that in mind. Clear this again. So more use cases: save pre-computed values, simplify repetitive code. So here is an example. I'm not sure what the pictures are here, but this is an example that's in the Princeton notes as well. We can quickly jump there. To simplify repetitive code, let's say if we want to specify the month of the year, if I say m equals 1, or this is actually not, this is not correct at all. Let me just go to Python example. I can show you the actual example for the years. It was in the notes. Again, I have done this already for these notes. So if you want to watch the videos, you can go to the list. There we go. So this is the example where they have if m is equal to 1 or 2 or 3 or 4, based on what m is, give the appropriate month of the year. So Jan, Feb, March, April, whatnot. So this is not correct. I'm not sure why they have this in the notes. But this is a bit of a tedious process. You can just do the same way by creating a months array or list and specifying it this way. So I'm going to copy and paste this and see what you get. Okay, didn't say anything, so okay, 1. So what did I do? I created an array, more correctly Python list, but we call it array. I have intentionally, or the notes, Princeton notes has intentionally left out the first element, the 0th element, just to make our lives easier. So if I want to see the first month of the year, I just say m equals 1, and I studio right line months access the months list, and I input what value is going to be here. It's going to be 1, and that's the first month of the year, so I guess Jan. If I make M12, it's going to be Feb. It's going to be December. So here's a, instead of repeating this course, you can just create one list that has all the months in it, and then use it in this way. Memory representation of an array. So recall that variables point to objects in memory. An array is a data structure